In this video, I want to start by talking to you a little bit about something called a tree diagram. Okay, so that's what's going to go in here at the very beginning, and we are in chapter 4 now. Okay, so a tree diagram. Tree diagram is a device used to list all possibilities of a sequence of events in a systematic way. Okay, so we're going to go through and organize all outcomes for a given event. Okay, so example, suppose a sales rep can travel from New York to Pittsburgh by plane, train, or bus, and from Pittsburgh to Cincinnati by bus, boat, or automobile. List all possible ways he can travel from New York to Cincinnati. Draw a tree diagram to show all possible ways. Okay, so we can do this either vertically or horizontally. I'm going to do this one. Hopefully I can get it all to fit on here. Okay, so I'm going to start here in New York, and I want to travel to Pittsburgh. So my choices for leaving New York are by plane, by train, or by bus. Okay, and then once I'm there, I can continue on my trek on to Cincinnati, and then at that point in time, I have a choice of doing a bus, a boat, or an automobile. So we'll go bus, boat, or auto, and we can continue that for all three of our choices here. Bus, boat, auto. And same thing over here. Sorry, a little tight on space. Bus, boat, auto. Okay, so then if you read the branches of our tree, we can generate all outcomes for our travel. Okay, so all the different choices. So we could do, and I'm going to abbreviate here if I can a little bit, a plane over here followed by a bus. We can do a plane and then a boat. We could do a plane and then an auto. Okay, secondly, if I start in here with train, okay, we can do train, bus, train, boat, train, auto. And then lastly, I'm running out of room. I can switch over here to start with the bus. So we can do a bus. I'm going to go across the bottom here. A bus followed by a bus followed by a boat, or a bus followed by an auto. Okay, so when that happens, then we can go through here and count how many outcomes we have. So we would have here 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can conclude that we have 9 outcomes for our travel choices. Okay, so that's called doing a tree diagram and then showing all the outcomes for that situation. Okay, all right, second example. A coin is tossed and a die is rolled. Find all possible outcomes of the sequence of events. Draw a tree diagram. Okay, so we will start with tossing that coin. You get either a heads or a tail. And then secondly, we will roll a die, normal die, 1 through 6. So 5, 6, so we get the numbers 1 to 6. 1, 2, 3, 4, 5, 6. So there's our tree. Okay, so then if we were to list our outcomes, okay, we would do a heads, one, 2, 3, 4, 5, 6, or tails. So we'd have 1, 2, 3, 4, 5, 6. And then if you were to count those up, you would find that we do in fact have 12 outcomes. If you were to count, you can also go across the bottom where your tree's diagram ends, and you would count to 12, and you would have 12 outcomes at that point. All right, next up on this little video talks about the fundamental counting rule. And you may have remembered this one, or you may remember this one from sometime in your math history. Okay, so this one, for each possibility, you're going to count your possibilities here, and then you multiply them together. All right, for example, a paint manufacturer wishes to manufacture several different kinds of paint. The categories include, okay, color, and if you count 1, 2, 3, 4, 5, 6, 7 different colors. If you count, there's 2 types of paint, latex and oil. Okay, as far as the texture, there are 3 of those. Indoor, outdoor, 2 of those. So to figure out the number of outcomes, you would take 7 times 2 times 3 times 2, and that would give you 84 ways to mix up that paint. Okay, all right, next up we have an example here with zip codes. Okay, so it talks about digits. So you got to think about how many single digits exist. Okay, and some people want to say 9, but remember 0 is a single digit. 8, 9. So really when you count, there are 10 single digits when you count across there. Okay, so if we want to make a zip code that has repeats, okay, can be repeated is the first part of the question. And you have 5 blanks. You have 10 digit choices for each blank. So you multiply that across and you come up with there are 100,000 different ways to make a 5-digit zip code if repeats are allowed. Okay, if there are no repeats, 5 digits. Okay, so you have a choice of 10 digits to start with. You pick one. Now you only have 9 digits left. Pick one. Only 8 digits remain. Pick one. 7 digits. Pick one. 6 digits. So when you multiply that all together, you get 30,240 different zip codes that you can create. Okay, that takes care of that one. All right. Next one. The manager of a department store chain wishes to make 4-digit ID cards for her employees. How many different cards can be made if she uses the digits 1 through 6 and repetitions are okay? So if repeats are okay and you want to do a 4-digit zip code from these digits right here, 1 through 6. So you have 6 choices, 6 choices, 6 choices, and 6 choices. So you get 6 to the 4th. Guess what? I added that on your paper. So we've got to do, how about that's 1,296 different outcomes. I don't think we'll make a tree diagram for that one. Okay, little joke there. And then the second one is if repeats are not okay, so no repeats. So if that's the case for your 4-digit ID card, you'd have 6 choices, then 5, then 4, then 3, because once you pick one, it's just going to reduce your total. Okay, so if you multiply that together, you have 360 outcomes. Okay, I think that pretty well takes care of you here at the very beginning of this. Sometimes when I do this first section, I also make a note. In fact, I'll sneak this down here to the bottom. There's something called a factorial. And some of you may know that. It's the happy sign. Okay, so sometimes in probability like this, it's useful to know, like 5 factorial, what that means is for you to multiply starting at 5 and multiply down to 1, the whole number. So like 5 times 4 times 3 times 2 times 1, or 120. Okay, if you do like 3 factorial, means 3 times 2 times 1. So 6. Okay, and if I'm recalling correctly, on your grapher calculator, if you go to Math, Prob, and here I am, I don't have one with me making the video. I want to say that it's choice 3, And you guys can tell me in class if that's right or not. But that's where your factorial button should live, okay? But once in a while, doing probabilities, that factorial saves you a little bit of time in calculation, okay? All right, so hopefully that's helpful for you, tree diagrams and fundamental accounting rule. Have a great day. Thanks for watching.